Let's look at solving some equations using completing the square. So by the way, just like factoring, when we said that guess and check is the most efficient method, but it's good to learn some other methods like diving into the box or splitting the middle term or things like that. Completing the square, is actually a necessary skill. There is no other way to deal with things when you need to complete the square, but you want to avoid completing the square if at all possible. So given the first example, we have an equation to solve. It's equaling 0. We have x squared plus 2x minus 15. There's no common factor here. We're not going to get x in one spot, so we're not going to be able to combine these like terms and do something with that. So in order to solve this equation, we look to factor first. So hopefully this factors. And in fact, it does. 5 and 3 and positive and negative. And because we're set equal to 0 on the other side, we can use a zero product property. Thus, if that is equal to 0, x minus 3 is equal to 0, or if x plus 5 is equal to 0, then if this thing's equals 0, it doesn't matter what this is, we multiply to 0. If this thing equals 0, doesn't matter what this is, we multiply to 0. So if those two things equal 0, we're okay. So therefore, x can be 3 or negative 5. All right, so we can solve this without completing the square. But in the next one, we can't factor. So when you cannot factor an equation and you have no other means to get x in itself in one spot in the equation so we can solve for x, you need to complete the square. That's going to be the procedure. So the first thing I'm going to do is I want to complete the square with this x squared plus 10x. So I'm going to move the 3 out of the way. So here I'm going to use a different marker. So just like when I had a y over here, I would get rid of that 3. I'm going to move the 3 over there just to get it out of the way. So x squared plus 10x, I'm going to leave a space, equals 3. All right. Now that space is being left for the completion of the square, In this case, that completion of the square is 25 because it's half of 10 squared. And if we add 25 to one side, we have to add it to the other side too. What this allows us to do is say that this side is equal to x plus 5 squared. And then the other side is equal to 28. All right, so this completing the square, we have to balance it off on the other side. And we choose this number specifically because it is 10 divided by 2 squared. And therefore, we can factor this trinomial to be x plus 5, because that multiplies back to that. But we had to balance it with the 25 over here, giving the 28. Now we can solve the equation because unlike a few steps ago when x was actually in this step too, where x was in 2 places, x magically is only in one spot. So we can take the square root of both sides. So x plus 5 equals the square root of 28. Now remember, when we take the square root of both sides, we wind up with a plus or minus here, because in order for this to be equal to what's inside of here, this side gets squared. It really has to do with absolute value, which I've shown you in class, but we have a plus or minus there. So then we have to subtract 5, and x is solved for. It's plus or minus root 28 minus 5. Now root 28 should really be written in simplest form. The root 28, remember, is 4 times 7. So that would be 2 radical 7 minus 5. Okay, so there's one example. I'll do another of these. This is getting into equations. We're solving using factoring if we can, but if we cannot factor, we're going to use completing the square. Notice that when we factor, we wind up with nice integer numbers. When we cannot factor and have to complete the square, we don't wind up with nice integer numbers, because basically factoring implies that there are nice numbers to deal with on the x-axis, which is where this 0 replaces y. That's kind of the conceptual idea of what works with that.